In this video, we're going to introduce the multiplication rule for probability. And the multiplication rule is if I am looking at two events that happen together or in succession. So the probability that A happens and B happens is equal to the probability that A happens times the probability that B happens given that A happened. And you'll remember from our last video, that's called a conditional probability. The first important piece is that when I see "and" in a problem, it's telling me to multiply. So we now have two sets of keywords. I know that "or" is telling me to add, and that "and" is telling me to multiply. So "or" means a single event can be, or a single result can be one or more events, meaning a single card in a deck of cards can be red and a queen, right? Or it could be red or a 5, or a jack or a 2. "And" means I want both things to be true at the same time. So this is an either or, this is a both have to be true. If A and B are independent, I know how to spell, sort of, independent. This rule becomes simpler because we know that B given A is just the probability of B. So if two events are independent, then the multiplication rule is that PA and B is just PA times PB. You're going to see me use this consistently because that always looks the same. And then I'm just going to remember that if A and B are independent, this is just equal to PB. What I want to take a minute to do is some examples so we can see what this rule looks like in practice. So let's go ahead and do some examples. This first one says the probability that a baby is born male in the US is 0.512. What is the probability that a family has 3 boys? So I'm going to write that using probability notation, and I'm going to let boy be the letter B. And what I want is this family wants a boy, and then another boy, and then another boy. That's 3 boys. Before I do my math, first thing I know, "and" means multiply. This is a multiplication rule. And then the second thing I have to ask me is, are these events independent? And since we are taking basic stats and we are not taking higher level biology, the assumption is that yes, the probability that a boy is born should be approximately the same for every birth in the family. So I know that this is just PB times PB times PB, because "and" means multiply, and I'm doing 2 ands, I'm doing 2 multiplies. And I know that for each, that probability is 0.512. Oh my goodness, I am sorry, I'm having technical difficulties today. So we grab our calculator, and you can do 0.512 times 0.512 times 0.512, or if you are like me and you know how calculators work, your calculator should have an X to the Y button, or if you're on a TI-84, it should have a caret button that will let you enter exponents on numbers. And since I have 3 of that 0.512, it's going to be to the 3rd power. And when I do that on my calculator, I get 0.1342. And as I mentioned in a previous video, we typically round our probabilities to 4 decimal places. So if this family has 3 boys, there is a 13.42% chance that that's going to happen. All right, next example. It says you are drawing cards from a deck for a game. You draw 2 cards. What is the probability that you draw 2 queens? So in this case, we want queens. We're going to call that Q. And we're drawing cards from a deck for a game, which means I'm probably holding those cards in my hand. So when I go to do this, P, queen, and queen, that's going to be P queen times P queen, given that my first card was a queen. So let's go ahead and take a look at what that looks like. I'm going to have fractions here. And I know for that first queen, it's a fresh deck of 52 cards. And there are 4 queens in the deck. So the probability of getting a queen on my first draw is 4 out of 52. When we go to do our second draw, I have removed a card from the deck. I'm holding a card in my hand, so there's now only 51 cards in the deck. I have also drawn a queen from the deck, meaning there are no longer 4 queens to choose from, there are only 3 queens to choose from. So this guy here is the conditional probability that I select a queen, given that my first draw was a queen. I'm going to go ahead and do this on a calculator. Remember to use parentheses so that the calculator does the operations in the correct order. So we want 4 out of 52 times 3 divided by 51. And when I date that, I get 0045. And remember to convert to a percent, we move the decimal place this way. That's about half of 1%. So it is very unlikely when you're drawing 2 cards from a deck that you're going to get 2 queens in a row. For 3, it says, what is the probability of flipping 5 heads in a row, assuming the coin is fair? So if our coin is fair, that means that heads and tails are equally weighted. So I expect that on each flip, it's going to be 50-50. So I want P, head, and heads. Oh my goodness, what is my pencil doing today? Heads and heads and heads and heads. I think there's 5 heads there. So we want 5 heads in a row. I know and means multiply. So I've got 0.5 times 0.5 times 0.5 times 0.5 times 0.5. And those probabilities don't change because flipping coins, each coin flip is independent. So that is 0.5 to the 5th power, because there are 5 of those numbers. And I'm going to plug that on my calculator. Let's see what we get. So 0.5 to the 5th. And I get 0.313. So a little bit more than 3% of those outcomes will be 5 heads in a row if I flip a coin 5 times. All right, if you have any questions on how to use the multiplication rule or how to figure out what a conditional probability looks like given the situation in a word problem, feel free to send me an email or drop by my Tuesday, Thursday office hours. Otherwise, I will see you in our next video.